Welcome to the section for hands-on projects. Here we will build 4 different projects and then go through the code each and every time and then see how we can make it better. The first one that we have is building a sentiment analysis model. Certainly below is a step-by-step guide for building a sentiment analysis model using TensorFlow, focusing on neural network architecture. Step 1 is data preparation. So with data preparation, the first thing that you have to do is data collection. Obtain a data set of text documents with sentiment labels positive, negative, neutral. You can use public data sets like IMDb, movie reviews, or Twitter sentiment analysis dataset. Next is data preprocessing. Preprocess the text data by tokenizing, padding sequences, and encoding labels. For example, tokenize the text into word or tokens. Convert words to integers using a tokenizer. Pad sequences to ensure uniform length. Step 2 is building the neural network model. Define model architecture. Build a neural network model for sentiment analysis using TensorFlow's Keras API. You can start with a simple architecture like a bidirectional LSTM followed by a dense layer. Compile the model by specifying the loss function, optimizer, and evaluation metrics. Next step is training the model. Split the data set into training and testing sets. Next, train the model. Train the sentiment analysis model on the training data. Use techniques like early stopping to prevent overfitting. Next step is model evaluation. In this, we do evaluate the performance. Evaluate the model's performance on the testing data using metrics like accuracy, precision, recall, and F1 score. Next step is model deployment. Save the model, save the trained model, weights, and architecture for future use, and then deploy the model. Deploy the sentiment analysis model using a suitable deployment strategy such as deployment as REST APIs using TensorFlow serving or Flask. Sixth step, or the last step, is continuous improvement. Fine-tuning. Fine-tuning the model architecture and hyperparameters based on performance metrics and user feedback. Update the model. Periodically update the sentiment analysis model with new data and retrain it to adapt changing trends and patterns. Here is example code. Let's go over this to see how we have implemented the sentiment analysis model. So first, we need to import TensorFlow. Then we have to import tokenizer from TensorFlow Keras preprocessing text. Next, import pad sequences from Keras preprocessing sequence. The first step for data preparation. Assuming text contains list of text documents and labels contain corresponding sentiment labels. We're going to tokenize and pad sequences. Use a tokenizer function. Pass num words equal to number of words equal to 10,000 and OOV token is OOV. Tokenizer dot fit on text function and pass the text to that. Next, we'll call the text to sequences function available in the tokenizer and pass text to it. Next, we'll call the pad sequence and pass the sequences max length of 100, padding of post, and truncating with post, and pass and assign it to padded sequences. This is data preparation. Now next is building the neural network model, which we have done before. Now we have to implement it here with calling the sequential function of the Keras and pass and call the embedding function, pass the values. Next is bidirectional, pass the layers LSTM that we are using. Next, the dense layers, we call the dense function, pass the 64 and activation value, and the next one pass 1 and activation of sigmoid. So next, we'll compile the model. So what we're going to do is we call the compile function, pass the optimizer as Adam, loss as binary cross entropy, and metrics as accuracy. Step 3, let's train the model. You pass xtrain, xtest, ytrain, ytest. These are the values that you'll get, tuple that you'll get from training test split function. You pass the padded sequences, labels, test size, and random state to it. Next, we're going to fit the model by calling model.fit function and pass it to give it to history. Xtrain, ytrain is what we pass, epochs of 10, validation data, xtest and ytest that we got, and then batch size of 32. Next step is model evaluation, where we call the evaluate function, and we pass the x test and y test to it and get loss and accuracy out. You can print those things out. Model deployment, you can save the model as I mentioned and then deploy it wherever you want using using either TensorFlow serving or anything else that you prefer. Step 6 is continuous improvement. So based on the feedback, you will fine tune the model, update the data, and retrain the periodically at this particular point. This example demonstrates how to build a sentiment analysis model using TensorFlow's Keras API. You can further enhance the model's performance by experimenting with different architectures, hyperparameters, and preprocessing techniques. Additionally, consider incorporating techniques like word embeddings, example word-to-vec or GLOV or glove, and attention mechanisms to improve the model's ability to capture semantic meaning and context in text data.